everyone, my name is Jacquelyn and today I'll be teaching about radians in degrees for the PCHS Pre-Calculus A-AB Unit 2 project. To begin, I'll explain what degrees and radians are, the relationship between degrees and radians, how to convert between them, and finally go over practice examples. To begin, degrees and radians are two different units used to measure angles. Degrees divide a circle into 360 equal parts, so one complete revolution measures 360 degrees. And radians measure angles using the radius of a circle instead of equal divisions. If we refer to our unit circle, we can see that a whole circle is 360 degrees, beginning here, wrapping all the way around back to 360. Again, with radians, we can see that it begins here, does a full revolution, and ends and results in 2 pi radians. Although they use different units, they represent the same angles. The most important relationship to remember is that one complete revolution is equal to 360 degrees or 2 pi radians. So if we divide both sides by 2, we obtain another important relationship. 180 degrees is equal to pi radians. This equivalence is the basis for every conversion between degrees and radians. Again, if we refer to our trig circle, we can see that half of a circle, or half a revolution, is 1 pi radian, or 180 degrees. Here we have two conversion formulas, using radians to find degrees. To find the degree of a radian, we can multiply the radian by 180 over pi. And from solving degrees into radians, we can multiply the degree by pi over 180. These fractions are called conversion factors because they convert one unit into another. During each conversion, the original unit cancels, leaving only the desired unit. Let's convert 150 degrees into radians. Since we're converting from degrees to radians, we multiply 150 by the conversion factor pi over 180, using the degree to radian formula. Next, we can multiply the numerator by giving us 150 pi over 180. Then we can simplify the fraction, because 150 and 180 are both divisible by 30. So by dividing both the numerator and denominator by 30, we can simplify and obtaining 5 pi over 6. Therefore, 150 degrees is equivalent to 5 pi over 6 radians. We can also use the trig circle to reference, and we look over here at 150 degrees, we can see that is equivalent to 5 pi over 6. Now, let's try again converting radians to degrees. Let's take 7 pi over 4 radians into degrees. Since we're converting radians into degrees, we multiply by the conversion factor 180 over pi, using the converting radians to degrees formula. Notice when we multiply by 180 over pi, it results in 1260 pi over 4 pi, and that the pi appears in both the numerator and the denominator, so these common factors cancel. Next, we can get 1260 over 4. Finally, we divide by 4, giving us 315. Therefore, 7 pi over 4 radians is equivalent to 350 degrees. And if we reference our unit circle again, we can look over here at 350 degrees and see that 350 degrees is equivalent to 7 pi over 4. So, today we learned that degrees and radians are simply two different units for measuring angles. And we learned that the key relationship that 180 degrees is equivalent to pi radians. And when converting degrees to radians, we can multiply by pi over 180. And when converting radians to degrees, we can multiply by 180 over pi. Finally, when converting radians to degrees or degrees to radians, it's crucial to always simplify your answers. Thank you for watching my presentation.